Hi everyone, this is Congestion from Department of Computer Science and Designing. So today we are going to see a topic called as congestion control and transport layer. Like here we are going to check how we manage the network traffic through empathetic problem solving and continuous evaluation. So actually the pain of network congestion is before we solve the network failure, we must understand the human experience behind the technical problem. Actually, the core issue is which is leads to shared resources in the scarcity in the tragedy of commons, like congestion collapse, making network unusable, user frustration from slow speeds and dropped connection. Like the normal speed will be 32K. When it is collapsed, like speed during congestion will be 40 bps, and the performance will be drop will be 800x. It may increase. What is congestion control and why it matters? Actually, the actual problem is the implicit mechanism of allocating network resources with and buffer space by reacting the scarcity when demand exceeds. Like the exact goal will be ensure the stable, efficient, and fair network operation across all users and applications, and which share in the infrastructure. The main key principle is it's preventing the congestion collapse, promoting fairness, and ensuring use of network capacity. So, how to explore the solution from loss to bandwidth? The two distinct approach to detecting and responding to network congestion, having emerging over time, and control based approach and the control congestion based approach. Control based approach, like reacting to packet losses as a signal of congestion using adaptive algorithm, where here it is a directly measuring bottleneck bandwidth and RTT to predict congestion. Here we are using Van Jacobson's classic algorithm, which we call it as cubic, and here it is BBR, like bottleneck bandwidth RTT. And here timeout calculation will be adaptive RTT estimation. And here it is packet is loss by signal and the buffer bloat or single buffers. Here it is a slow start and here it is more accurate condition assessment. And here it is a gradual probing for available bandwidth. Here it is a proactive congestion. So how to building the algorithm? Like in first RFC 5033 framework, like initial guidelines for developing new congestion control algorithm with evaluation criteria. And RFC 9743, which is a BCP 133 we call, which is a comprehensive testing and validation framework, obsoleting RFC 5033 to prevent adverse interaction. And L4S architecture is a low latency, low loss, and scalable throughput using modified ECN signaling RFC 930. Here it is a single algorithm evaluation and mixed algorithm behavior. Like a single algorithm evaluation is protection against collapse, buffer flow prevention, high packet loss handling, fairness within algorithm. And mixed is coexistence with classic control and minimal performance impact and backward compatibility. So how to evaluate the congestion control effect? Like through single algorithm behavior and mixed algorithm behavior. Single algorithm, we see how well does the algorithm perform on its own under various network conditions. Protection against the collapse and protection against buffer flow, protection against high packet loss, fairness within the algorithm. And in mixed algorithm behavior, how does it react with the existing algorithm and real world mixed environment, like coexisting with the classic congestion control. L4S aims with the minimal impact of classic performance and ensuring backward compatibility. So how would evaluate from reactive to proactive? Like reactive approach, which nothing but which is the traditional algorithm like cubic react after congestion is detected through packet loss or time. And reactive approach, which is a BBR, like bottleneck backward, and similar algorithm aim to predict and avoid congestion by understanding network condition directly. In 1986, they have used Van Jacobs TCP congestion control algorithm. In 2006, Cubic becomes the default Linux TCP congestion control. In 2016, BBR introduced by Google. And 23 RFC 9743 updates evaluation framework. The real world impact, like L4S mission, which is the main goal is it enables the application to both low latency and high throughput simultaneously. The mechanism here used is modified explicit congestion notification to signal congestion. Earlier, more precisely, traditional packet loss detection. And the main benefit is here it is application can transition away from algorithm, causing substantial queuing delay, improving users' experience and across video gaming and real-time communication. Here where we are using the real world impact is on video streaming, online gaming and real-time communication. So the future will be stability and innovation with the 2023, which is in the RFC 1940s, 9743 framework. And the main focus area is in IoT, constrained nodes with limited resources, multi-path transport protocol, data center optimization. So the continuous improvement will be going on, and IoT challenges will be billions of devices with the constrained resources required, lightweight congestion control. And here they have used multipath transport and data center network. So here we can frame evolving the network through design thinking, like empathize, define, test, ideate, prototype. Like understanding the user frustration, we have to understand the problem first. Defining is clarifying the congestion control as implicit resource, etc. And ideate is something exploring the loss-based and bandwidth-based approaches, and then prototype building algorithm in RFC framework, and test comprehensive evaluation will be done for the single and mixed behavior. The mind map we have used here through the transport layer protocol.